Picture a nebula, a cosmic cloud splashed with colors so vivid they seem to belong in a dream. Fiery reds, deep blues, ethereal greens swirl together, creating a spectacle that feels almost otherworldly. These celestial masterpieces aren't just beautiful, they're storytellers, revealing the secrets of stars, gas, and dust in the vast universe. But what makes nebulae glow with such breathtaking intensity? Why do they burst with hues that captivate our imagination? Today, we're embarking on a journey to uncover the science behind the vibrant colors of nebulae, exploring how they form, what they're made of, and the tales they weave about the cosmos. This isn't just a visual feast, it's a scientific odyssey into the heart of the universe's most dazzling displays. Get ready to discover why nebulae are the ultimate light show of the cosmos. Let's begin with the essentials. A nebula is a colossal cloud of gas and dust drifting through space, sometimes spanning hundreds of light years. These clouds are primarily composed of hydrogen, the universe's most abundant element, mixed with helium, traces of other gases like nitrogen and oxygen, and tiny particles of dust made of carbon or silicates. Nebulae come to life through various cosmic processes. Some are born from the explosive deaths of massive stars, others form when interstellar gas clumps together, and many serve as cradles where new stars ignite. Nebulae aren't one-size-fits-all. Emission nebulae glow brightly, powered by the energy of nearby stars. Reflection nebulae shimmer by scattering starlight like cosmic mirrors. Dark nebulae block out light, casting eerie shadows. Planetary nebulae, despite the name, are the glowing shells cast off by dying stars, not planets. Each type has its own character, but they all share a common trait: their ability to mesmerize us with colors. These hues aren't random. They're windows into the nebula's composition, temperature, and the dynamic forces shaping it. Understanding nebulae means unlocking the code of their radiant beauty. So, what gives nebulae their stunning colors? It's all about the interplay of light, gas, and energy. The colors we see depend on how atoms and molecules in the nebula react to radiation, particularly from nearby stars. When intense ultraviolet light from a hot young star strikes the nebula's gas, it excites the atom's electrons, boosting them to higher energy levels. As those electrons fall back to their normal state, they release energy as light, and the color of that light hinges on the element involved. Hydrogen, the nebula's dominant ingredient, emits a striking red glow at a wavelength called H-alpha, around 656 nanometers. Oxygen, when ionized, shines with a vivid green, often at 500 nanometers. Nitrogen and sulfur contribute reds, pinks, or deeper crimsons, while helium can add faint blues or purples. These colors are like chemical signatures, letting astronomers decode a nebula's makeup by studying its light spectrum. But gas isn't the whole story. Dust plays a role too. In some nebulae, dust scatters starlight, favoring blue wavelengths and creating a soft, sky-like glow. This intricate dance of light and matter transforms nebulae into glowing tapestries of color. Each type of nebula paints the sky with its own palette, shaped by its environment and processes. Emission nebulae are the rock stars of the group, blazing with color thanks to the radiation from massive stars within or nearby. The Orion Nebula, just 1,300 light-years away, is a prime example, a vibrant blend of reds from hydrogen, greens from oxygen, and hints of blue from scattered light. These nebulae are often stellar nurseries, where newborn stars ignite the gas, making it glow like a cosmic beacon. Reflection nebulae, on the other hand, don't produce their own light. They reflect the glow of nearby stars. Their dust grains scatter blue light more efficiently, giving them a delicate azure hue, much like the scattering that makes Earth's sky blue. The nebula enveloping the Pleiades star cluster is a stunning case, its misty blue veil shimmering against the starry backdrop. Planetary nebulae offer another spectacle. Formed when a star like our Sun sheds its outer layers, these nebulae glow under the intense radiation of the star's exposed core, now a white dwarf. The Ring Nebula in Lyra is iconic, with a bright green center from oxygen framed by red hydrogen, creating a jewel-like effect. The variety of ionized gases, oxygen, nitrogen, helium, produces a rich, multi-layered palette. Dark nebulae, like the Horsehead Nebula in Orion, take a different approach. These dense clouds absorb light, appearing as black silhouettes against brighter backgrounds. While they lack their own colors, their stark contrast with glowing reds or blues behind them adds drama to the cosmic scene. Each nebula type with its distinct colors tells a unique story of creation and transformation. Stars are the master painters of nebulae, their light and energy shaping every hue. Massive young stars, classified as O or B types, are the heavy hitters. These stellar powerhouses emit torrents of ultraviolet radiation, ionizing the surrounding gas and setting it aglow. The hotter the star, the more intense the nebula's shine, which is why emission nebulae like the Tarantula Nebula in the Large Magellanic Cloud dazzle with radiant colors. Cooler stars, like A-types, play a subtler role in reflection nebulae. Their light, rich in blue wavelengths, gets scattered by dust, creating a gentle glow that contrasts with the fiery reds of emission nebulae. In planetary nebulae, the central white dwarf, small but scorching hot, drives a symphony of colors. Its radiation excites a range of elements, producing greens, reds, blues, and even purples, as seen in nebulae like the Helix, with its intricate layers of glowing gas. Supernovas, the explosive deaths of massive stars, also leave their mark. Their remnants, like the Crab Nebula, glow with greens and reds from heavy elements like oxygen and sulfur, forged in the star's final moments. The age, temperature, and type of star dictate a nebula's colors, turning these clouds into living artworks sculpted by stellar light. Nebulae may be vibrant, but their colors don't always leap out when viewed directly. Through a small telescope or even the naked eye, many appear gray or faintly green because human eyes struggle to detect specific wavelengths in dim light. The breathtaking images we associate with nebulae, like those from Hubble or James Webb, are the result of sophisticated technology and artistry. Telescopes collect light across a spectrum, from visible to infrared or ultraviolet. Astronomers use filters to isolate emissions from key elements, hydrogen, oxygen, sulfur, and assign colors to make the data visually clear. For instance, hydrogen might be mapped to red, oxygen to green, and nitrogen to blue. These false color images aren't exactly what we'd see, but accurately represent the nebula's chemistry in a way that's striking and understandable. Long exposure photography is another game changer. By gathering light for hours, telescopes reveal details and colors invisible to the human eye, like the golden-green pillars of creation in the Eagle Nebula. This process transforms faint smudges into vivid masterpieces, showing us the universe's beauty in ways our biology alone couldn't. It's a blend of science and creativity that brings nebulae to life. The colors of a nebula are like a chemical roadmap, with each hue tied to a specific element. Hydrogen, the nebula's backbone, glows red at the H-alpha line, 656 nanometers, giving many nebulae their fiery base tone. Ionized oxygen shines green at around 500 nanometers, a hallmark of planetary nebulae like the Cat's Eye, where it creates an almost emerald-like radiance. Nitrogen, when ionized, adds reds or pinks, blending with hydrogen to soften or deepen a nebula's glow. Sulfur contributes richer reds, often seen in supernova remnants. Helium, though less common, can introduce blues or purples, adding subtle accents. These emissions are precise. Each element's light forms a unique spectral line, like a cosmic barcode. By studying these lines, astronomers can measure a nebula's composition, temperature, density, and even its motion, unraveling its place in the universe's grand story. Dust shapes colors too, though differently. In reflection nebulae, it scatters blue light, creating a misty glow. In dark nebulae, it absorbs light, framing brighter regions with inky voids. The balance of glowing gas and light-scattering dust makes every nebula a chemical and visual marvel. Nebulae aren't static. Their colors evolve as they age. A young emission nebula, like Orion, burns bright with reds and greens, fueled by the raw energy of massive stars in their prime. As those stars mature or explode as supernovas, the nebula may fade, disperse, or morph into a remnant like the Veil Nebula, where colors shift to reflect heavier elements like sulfur and oxygen released in the blast. Planetary nebulae, such as the Dumbbell Nebula, are fleeting by cosmic standards. Their white dwarf cores ionize the surrounding gas, producing brilliant greens and reds, but within tens of thousands of years, the gas spreads out, and the colors dim. Reflection nebulae, like those around the Pleiades, rely on nearby stars for their blue glow. If the stars drift away or dim, the nebula loses its luster. Dark nebulae can transform too. A shockwave, say from a supernova, might compress the cloud, sparking star formation and turning it into a glowing emission nebula. The Lagoon Nebula, with its vivid reds, likely began as a darker cloud before stars ignited within. A nebula's colors are a fleeting chapter in its life, capturing moments of birth, brilliance, and eventual fade. Beyond their scientific value, nebular colors have left a deep mark on human culture. In ancient times, faint nebulae like Orion's were seen as omens or divine signs, woven into myths across civilizations. Today, their images are everywhere, on book covers, in sci-fi blockbusters, in digital art, symbolizing the vastness of the unknown. The Eagle Nebula's pillars of creation, with their glowing greens and golds, are more than a photo. They're a cultural touchstone, inspiring awe and wonder. For scientists, nebular colors are a treasure trove. They reveal the universe's chemistry, from the dominance of hydrogen in early galaxies to traces of rare elements in dying stars. They help us trace star formation, measure galactic evolution, and probe the conditions of the Big Bang's aftermath. Each color is a clue, helping astronomers build a clearer picture of cosmic history. New telescopes, like James Webb, are pushing the boundaries further, capturing colors and details from nebulae billions of light years away. These images don't just deepen our understanding, they remind us that the universe is a place of staggering beauty, where every hue tells a story. Nebulae bridge the gap between human curiosity and cosmic reality, inviting us to marvel and explore. Nebulae are more than cosmic clouds. They're the universe's greatest canvases, where light, gas, and stars create a symphony of colors. From hydrogen's fiery red to oxygen's mystic green, each hue reveals a piece of the cosmos' story, blending creation, energy, and transformation. Whether they blaze like beacons or linger in shadow, nebulae connect us to the stars, showing how beauty and science intertwine in the vastness of space. The next time you see a nebula's vibrant glow, know you're not just seeing colors. You're glimpsing the heartbeat of the universe, alive with the radiance of creation.